Okay, so today's daily question is four divisors. Given an integer at a num, return the sum of the divisors of the integer in that array that have exactly four divisors. If there is no such integer in the array, return 0. Okay, so first we have to know the maths behind it. So for an integer to have, for a number to have the four divisors, there are two conditions. Either first, number should be equal to p cube. How we write cube in Python like this, p cube, where p should be prime. Only then it can have the four divisors, and the divisors will be first one, second will be p, third p square, and fourth p cube. And the second condition to have the four divisor is number should be in the form p into q, where p and q should be prime numbers, should be distinct prime numbers, both should be different. Otherwise, it will be p square. Should be distinct prime numbers, and divisors divisors will be one, then p itself, then q, and then p star q or the number itself. So let's try to code this. So first we will be requiring to check the prime number. So let's first write the code to check prime. Everyone know how to check for the prime, right? So if x is less than 2, simply return false. Otherwise, we will be requiring the math module too for getting the square root. So simply go for I in range from 2 to int of math dot sqrt of, we are getting the square root of the number, and plus 1 so that it will go till the number, till the square root, not one less than that. Now if x modulus I is equal to 0, it means this is not prime, so simply return false, else return true. Okay, so our prime number code is ready. Now let's go through the given list. So for number in nums, let's check the first case first, this one. It is in the form num is equal to p cube. So first let's take out the root of the number. How do we take out the root? Simply for finding the root we have to multiply it by 1 by 3. So the given number is this, power 1 by 3, and as this will be the decimal, we should simply round this up. Okay, now if root cube is equal to number itself, and root should be prime number, so we will check that also. And is prime root, we have created this prime function already, so is prime root, then we can simply add to the answer. Now we have not defined the answer before, so let's define it. Answer is equal to 0. Answer plus is equal to what I told you earlier, that what all will be the divisor. This 1 p square p cube, so simply add 1. P is nothing but the root, then again root into root, simply root square plus, you can simply give in place of root cube, you can give the number itself, and continue. And if this case does not match it, we should go for the second, that's number is equal to p into q. So simply go from the range. As we know the prime number start from the 2, so we will start with the 2 for I in range 2 to int of math.sqrt of the number. What is the number here? Plus 1. Now simply if number modulus I is equal to 0. Okay, if number modulus I is equal to 0, then we will get the another number by number double divided by I. Now how to check it? Does it match the second condition or not? So if first both I and j should be different, if I is not equal to j and both should be prime, so is prime I and is prime j. So if this matches, so answer plus is equal to what I told, what all will be the divisors 1 p q and the number itself all p into q. So 1 plus what is the number here? First one is I, second is j, or and third one you can simply put the number or I into j, anything whatever you wish. And if this is not the case, so simply there can't be two different prime numbers such that the multiple is the number. So simply we can break through the loop. Okay, and finally we will return the answer. Let's see if this work. Okay, so test cases have been passed. Let's try to submit this. Yeah, so our code has passed successfully. Thank you.